simultaneous equations. Here we are asked to find the value of x and y, okay? So you have x and y. We have to find the values of x and y. But here, you see that here the equations are in indices form. So the first thing you have to do is to break them down to a normal equation before you can solve them. So let's look at how to solve this particular problem. Now, over here we have 3 as a base, exponent x plus 1. Here is 27, because we want to rewrite them nicely in normal equation form. Here, because the base over here is 3, so here we have to look out for a base of 3, or we have to ask ourselves, is there any way 3 can raise to a certain exponent for me to get 27? Is it possible? Yeah, so over here you can see that it is possible, which is 3 exponent 3 will give us 27. So in place of 27, we can replace the 27 with 3 exponent 3, so that it can help us to equate the exponent, right? So over here, we have 3 exponent x plus 1. This one should be equal to 27 is now 3 exponent 3. Make sure you put the already exponent over there in brackets so that it doesn't confuse you. So now 3 exponent 3 is going to give us 27. So we have it in this way. Now the bases are now the same. And we know that from the laws of indices, when the bases are the same, we equate the exponent. So over here, we can bring the exponent down. So we have x plus 1 to be equals to, here, let's try and expand it straight away. 3 times 1 will give us 3y. Then we have minus 3. Okay? So here 3 times y, 3y, 3 times minus 1, minus 3. So we can rewrite this one nicely by grouping them. We have x, bring this one to come and join them here. Minus 3y. Okay, so this negative, when it comes over, it becomes positive. So we are going to have plus 4 equals 0, right? This is our first equation. So let's label it equation 1. Then we come back to the second part. We have 1 out of 3 to the exponent of 2x to be equals to 1 out of 9 to the exponent of y plus 2. So what we do over here is we have to break this one also down from this indices equation to a normal equation form. Okay, so we know that in terms of indices, 1 out of 3 can be rewritten as 3 exponent minus 1. Okay, 1 out of 3 can be written as 3 exponent minus 1. Then we have our exponent still over there. And this one should be equal to, we know 9 can be broken down in terms of indices as 3 exponent 2. Okay, 3 exponent 2. Then this 3 exponent 2, when we send it back, okay, when we send it upside, when we send it to the numerator, okay, it's going to give us 3 exponent negative 2. So down here, the 2 will be positive. So when everything is going up, the 2 becomes what? The positive becomes negative. In the same manner with this one, if we want to send it down, then our negative sign will go off. It will become 1 out of 3 exponent 2. Okay. So this is the simplest way of breaking them down. Then we have our exponent, which is y plus 2, sitting there nicely. So over here we can expand them by, we have 3, this time this will give us minus 2x. Okay, to be equals to, over here too we can expand them because this is a binomial, minus 2 times y. We have minus 2y, minus 2 times 2, minus 4. Now you can see the bases are now the same. So we can equate the exponent, right? So we are going to have minus 2x to be equals to minus 2y minus 4. Okay? And this is going to give us, if we rearrange them, let's make x positive. We're going to have 2x minus 2y minus 4 to be equal to 0. This is our equation 2. So over here from our equation 1, we know that x minus 3y plus 4 equals 0, right? So from here we can make x the subject from equation 1. We can make x the subject over here because here x is standing alone. So it will be easier and faster for you to make x the subject. Okay, so we send everything into that side of the equation. So from equation 1, we have x to be equals to 3y minus 4. So from equation 1, we know that minus 3y is going to the other side of the equation, which will become positive. Then plus 4 is also moving, which will become minus 4. Okay, so now that from equation 1 we have x to be equals to 3y minus 4, here you can see that there is a common factor which is 2. 2 can divide through, right? If you want, you can divide it through, or better still, you can leave it like that and solve it to so get your answers correct. So let's fix our x inside equation 2. So 2 multiplying 3y minus 4 minus 2y minus 4 equals 0. Okay. So let's expand this one. We have 6y minus 8 minus 2y minus 4 equals 0. So 6y minus 2y, we are going to have 4y. Let's send 8 minus 8 minus 4 is going to give us minus 12. Send it to the other side of the equation. We are going to have minus positive 12 over here. Let's divide this by 4. Here by 4. This will cancel this. Y is equals to 3. Alright, over here it was 3. So over here with the 3, we can fix 3 inside this particular equation over here. And we are going to have our value for x. So we have x to be equals to 3 multiplying 3 minus 4. And this is going to give us 9 minus 4, where our x is equals to 5. So this is the solution for our x and y. Now we realize that our y is equals to 3. So after getting your 3, you fix it inside your equation. From equation 1, we know that x is equals to 3y minus 4. So straight away, wherever you see y, you put your 3 over there. Then you multiply by your 3, which is making 9. Subtract 4 from it, and you are getting 5 for x. And this is our solution for the problem.